Alright, class, it's time to begin our next lesson. Today we'll be solving one-step inequalities. And you might be thinking, wait, have we done this already? No. We have worked on problems where we were solving one-step equations, but not inequalities yet. Well, I do have some good news. The good news is that this is going to be basically the same thing as solving one-step equations. So if you've got a good grasp on that at this point, you should be able to do pretty well in this section. There's just two main differences, and we'll go over those as we go through the lesson. If you've not yet grasped solving one-step equations, I did tell you that this would be very important because you would use it for other things we were going to do. So I hope that you now understand you need to take me seriously and make sure that you understand the material. All right, so get ready for some notes. So you can find more resources on these pages. They, go with these sections right here. The actual titles for these are actually solving one-step inequalities with adding and subtracting, solving one-step inequalities with multiplying and dividing. I just put solving one-step inequalities to simplify it. But we will start with solving, and we will start with some adding and subtracting problems. So we're told to solve. Example 1, let's look at example 1a. Now if this was an equation, we would have a equal sign right here and not an inequality symbol. But since we have an inequality symbol, this makes it an inequality. But we treat it the same exact way, okay? So the only difference is, for this one, the only difference is the symbol. And we just need to make sure that we keep the symbol, that symbol. We don't need to change it or do anything to it. A lot of students, for some reason, want to turn this into an equal sign for their final answer, but that is incorrect. Some students have questions why. I don't mind answering your questions why, but you just need to trust me on this for right now, that don't go changing that, okay? Keep it an equality symbol. Do not, if you put equal symbols anywhere in the notes on here, it will be wrong. If you do that on any work that we do for solving inequalities, it will be wrong. So let's not do that. So we work it the same way we normally would. We would subtract 7. And please remember, I do recommend that you might want to get a different color. I'm doing mine in pencil. But you might want to get a different color pen or something so that when you're doing your notes, you'll see that what you actually subtracted. Because when you look back, you might forget, okay, what was the original and what did I do to it? So remember, my recommendation, use a different colored pencil. It might help. So we subtract 7, and you end up with 7 is greater than or equal to 12. And that's all there is to that, okay? Following the same rule over here. Now remember, how do you get rid of a negative? Here we have a negative, we have plus a negative 18. Well, you could say subtract negative 18. That's going to get rid of this. But what is subtracting a negative, really? What is it really? It's adding a positive. So I could just say I'm going to add 18 to this side, and I'm going to add 18 to this side, all right? So I end up with, my symbol stays the same. I have my x right here by himself. He's on this side of the inequality symbol right now. Now, what happens when I have negative 5 plus positive 18? I get positive 13. So 13 is greater than x. But if you notice, we typically write it with the x first, the variable first. And that is how you need to write it here. You're going to need to put the x is less than 13. I thought you said we're supposed to flip it. You don't flip it while you're doing the work. At the very end, if you've got the x on the right side, we need to get the x on the left side. So in order to make this sentence still true, we have to flip the entire thing. And we'll go over some examples in class of why that is. So make sure you're paying attention. Okay. Next, here we have n minus 18. So how do we cancel subtraction? Well, we use addition. So we add 18 to both sides. You get n is less than what? N is less than 21. Over here, we would have to add 6 to both sides. R is greater than, well, negative plus a positive. It depends on, is our answer going to be negative or positive? Well, it depends on which number looks bigger. The 17 looks bigger. It's negative, so we get a negative. Basically, now we just subtract 17 minus 6, and you get 11. So negative 11 is the answer, okay? I told you also, you got to make sure you understand positive and negatives and how they work back and forth. You've got to remember those rules. It is very important. We will use it. I mean, we've learned it like a month back, and we're still using it now. We will use it throughout the entire year. Okay? Put some effort in. Make sure you learn it. All right, next we have 5x is less than or equal to 70. When they're touching, it means to multiply. Now, to cancel multiplication, we have to use division. So we use division to divide. Remember, I recommend that you put a different color when that you write. You could write all this out in pencil, but then use a different color when you put the divide by 5. That way, it doesn't look like the original problem had a fraction in it. Okay. So we divide both sides by 5. So x is less than or equal to what? X is less than or equal to 14. Okay? 14. Now, I remember at the beginning I told you that there's 2 differences. We've already gone over one difference. One of the differences between inequalities and equations when solving them is that there's an inequality symbol instead of an equal sign. Okay? Simple enough there. I hope that was a given. We should have known that. Here's the other difference, and it's going to be shown in this example. What I'm going to do now, I'm going to work it out, and let's see if you see what I do differently. So I have to divide by -4, divide by -4. That's the exact same thing that we do when we were solving equations. So I end up with x is greater than or equal to -8, because 32 divided by -4 is -8. Does anyone notice something that changed here? I hope you do. If you look closely at the symbols, you'll notice it's facing a different direction, and that wasn't by a mistake. Here's what you need to know, that in order to solve inequalities, you're going to have to add, subtract, multiply, or divide. But if you multiply or divide both sides by a negative, if I multiply both sides by a negative or divide both sides by a negative, the inequality symbol has to flip. Nothing else flips. The x stays over here, the 8 stays over there. The symbol, though, flips. We'll go over in class the why. You just need to know that that does happen. Your answer will be counted wrong if you do not flip it on problems like this example, okay? So that is the correct answer. You might want to get a highlighter out and I would highlight this inequality symbol and this inequality symbol just to make you see, oh, they flip. And maybe you could also highlight these negative marks right here, the negative marks right here. That way you could say like, oh, I flipped it. Why? Oh yeah, because of those, because it's negative, okay? And we'll explain more in class, as I said. All right, next we have x divided by 6. Well, what cancels that out? Well, we could just times it by 6 times both sides by 6, and you get x is less than what? X is less than, what is 6 times 7? Well, that would be, what is it, 42? 42. Now over here, we got a -4. To get rid of it, we're going to multiply both sides by that. So this a is now by itself. 11 times that is -44. What goes in the middle? An inequality symbol, obviously. But which one? Do we put greater than down? But remember what the rule from the example right above this one? If you multiply or divide both sides by a negative, you've got to flip the symbol. We multiplied both of the sides by -4, so we have to flip it to the less than symbol. It was greater than, now it's less than. Maybe you should also get a highlighter out and highlight these two symbols and then highlight the negatives in front of the 4s, okay? So that I think would be very helpful for you to do. All right, hopefully you understand all this and we're good to go.